Hello and welcome. Today we're going to take a look at a new problem verifying an alien dictionary. It's Leetcode 953, and the statement is as follows. In an alien language, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. And we are given here three different examples. First, we have the words hello and Leetcode and the order H, L, and then the regular alphabetic order for the other characters, A, B, C, etc., X, Y, Z. And here the order is true because H comes before L in the order. And then in the second example we have word and world, and the order is world, A, B, C, and so on. And it says here that as D comes after L in this language, then words of 0 is greater than words of 1, hence the sequence is unsorted, so it's false. And then in the third example we have the words apple and app, and we see here we have the prefix app for both words, but the first one is larger, and that's not a valid order, so it should be app and apple. That's a valid order. Here we have the regular order of the English alphabet. Okay, so let's go to the drawing and see what we can do to approach this problem. So we have here two of the examples. First, we're going to take a look at the hello Leetcode words with the given order here. And when we compare, when we iterate through the words, we compare the first word, hello, with the second word, Leetcode. Okay, and what we compare is actually letter by letter. We compare the characters. So we compare H with L. So then if we have a difference which on the first position, which we do, so H is different from L, then we need to check the order. So how do we check the order? The order is given by the string above me, from above, sorry. So this order, the string here is a given order, and we see that H comes before L. But how do we use this information? So one way to do this is to use a map, but we can also use a vector, and that's what we have here on the left. We have H minus A, position H minus A will equal index 0. Position L minus A will equal index 1. A minus A, which is 0, will equal 2, and so on. So here we can see that 0 is not greater than 1, so the order is valid. So we just check the first differing character, which is this one. H differs from L. This is the first differing character, and we check, is the order for this index greater than the second word, and if for some reason it is, then we return false. But in this case, it's a valid order. So you can say index of H is going to be less than index of L. So that's fine. And because of this, we just break out of the loop, because we just check the first differing character and we're done. The two words are correct. They are sorted in lexicographical order. So this was the first example. Now let's take a look at the second example. And in particular, if we consider again app and apple, this is going to be valid, right? Because this, again, we are not using the order above here, we are using the regular English alphabet, alphabetical order. So this is valid. But if it's like here on the left, it's not valid. So here we check first A with character A. They are the same, they are not different. We check character P with character P. They are the same, they are not different. We check character P with character P. They are the same, they are not different. So then we exit the loop because we only go to the length of the smallest of the two words. So we exit the loop here, and you notice we would normally return true at the end, but we have to add some condition to return false in this case because what we have on the left is not a valid ordering. And what we have to do is we can check if the size of first is greater than the size of second, and we have not found a difference, right? We have not found a difference. So all the words are all the characters are equal up to this point. A, P, P, all the characters are equal as far as we can check. And if no difference is found and the first word is greater than the second, then we return false. And that's it. That's the whole problem. Okay, let's go and code this. So first we define a vector of int called index. Size is 26 because we have 26 English letters in the alphabet. And then actually we need the index of this. We go through the order for the string. And here we have the element of I, but we want the index in a vector, right? So then we do minus the character A. So A minus A would correspond to index 0, B minus A would correspond to index 1, C minus A would correspond to index 2, and so on in a normal ordering. In this case, we'd have H minus A is going to be equal to 0, right? So position 8 or okay. So, and then we have index for the second one would have index of L. L minus A is going to be 1, and then A minus A is going to be 0. Okay, so then we iterate through the words. So we take the first word as word of I minus 1, and we take the second as words of I. So these are two words. Now we have to compare the characters in the words, right? But before we do that, we need to identify the limit until we iterate. So we're going to go until we hit the smallest of the two word lengths. So for each character until the last one, we check if first of J is different the second of j. And if this is the case, we break because we have a difference. And now we have to check the ordering, right? So if index of first of j minus a is greater than index of second of j minus a, return false. And I have to write the if as well. Okay, if index of first of j minus a is greater than index of second of j minus a, we return false. So again, if the index of the first letter is somehow greater than the index of the second letter, we will return false, because that means that the order is invalid. We have something that should come after it, before it. And then otherwise we return true. And this should cover the first case. So if I run this now, oh sorry, return true if we don't find any difference here. And now we can see the first two cases are correct, but case 3 is wrong, apple and app, because we haven't dealt with this situation. So in order to fix this, we said we're going to check here, we're going to add a condition, and we're going to check if first size is greater than second size, and then we said if we haven't found the difference, then we return false, right? Because in this case we have a situation like apple and app, where we have all the letters, the common letters will all be equal in the two words. We'll have A, P, and P. And in this case, if the first word is greater than the second word, we want to return false, because this is not a valid ordering. So here I'm just going to say found if is false, and if this is true, found if is true. So now if I run this, case 3 passes as well. And we have passed, it's accepted 100%. Okay, so now let's discuss the complexities. Time complexity and space complexity. So for the space complexity, we have O1, because the vector is limited to 26 characters, right? So it's always the same, 26 characters, so it's O1. It never grows with the input. Okay. And for the time complexity, we have 2 for loops here. So one is to get the words, and next we iterate for the characters. So we'd have, so there are multiple ways to report the time complexity. In this case, I'm reporting it based on the number of words in the array and the average length of each word in words, n and m, and it's going to be O of n times m. So if we submit this again, it's going to say the same thing here, O of n times n. So that's it for today. I hope you enjoyed this problem. I hope my explanation was clear enough for you to understand. If you liked the video, please like and subscribe. And stay tuned for more C++ problems. Thank you and bye.